For example 1, I want to graph the function f of x equals negative 3x minus 1. And I know this has the form of a linear function. So my approach is going to be, I'm going to find 2 points, plot them, and sketch the line going between those 2 points. So I'll do a little work off to the side, but it doesn't matter what x values I choose. I just think maybe 0 would be a good one to start with. So f of 0, I want to know what that is equal to. If I put 0 into this equation, I'll do that work below here. So that's negative 3 times 0 minus 1, which completely reduces to negative 1. So I get negative 1. And I need one other point. I could choose any x value that I like. So I'm going to try, I guess, negative 3 to see what happens there. So what is f of negative 3? So that means when x is equal to negative 3, what is the corresponding y value? So that's going to be negative 3, and I'm putting negative 3 in place of x, and then subtracting 1. Negative 3 times negative 3 is a positive 9, minus 1 gives me 8. So now I have 2 points on my equation. So let's see. Give me a little bit more space here. All right, I think I'll start by plotting f of 0 is equal to negative 1. So that's right here. That's the point 0 for x and negative 1 for y. My other point is going to be negative 3 comma 8. So that is 3 places to the left and up 8. So that is here. So these are 2 points on my line. So I'll now sketch the line that goes between them. So I can use a line tool for that, but let's see, it would look like this. Maybe to get another one going forever in the other direction, I have one going up here like that. But this is it. This is the line that goes between those 2 points. I had a couple other questions about this example, and that was, all right, what's the slope, what's the y-intercept, and what's the x-intercept? So for starters, I know the slope, m, is going to be negative 3, or if you want to be more careful, negative 3 over 1. That's the number that was next to the x. All right, so the y-intercept is where it crosses the y-axis. Just to maybe highlight that again, that's located right here. So that is b is equal to negative 1. Or if you wanted to be more careful, it's really the point 0, negative 1. So it's like actually on the y-axis. And I also asked about the x-intercept. So that would be located right here, where the graph actually crosses over the x-axis. So maybe just to set up what that looks like, I have a function f of x is equal to negative 3x minus 1. Now there's nothing written in this equation that tells you what the x-intercept has to be. You actually have to solve an equation to figure that out. I'd actually like to go through that right now. What we're going to do is take the equation and set it equal to 0. What this equation is doing is saying when the y value is 0, what's the corresponding x value? And that would have to indicate the point where it crosses the x-axis. Okay. Solve this equation, I'm going to add 1 to both sides. And then I'm going to divide both sides, should be a positive 1. Divide both sides by negative 3. And my answer is x is equal to negative 1 over 3. So in terms of the x-intercept, the x value is negative 1/3, and the y value is 0. For example 2, again, kind of like the previous example, I'd like to graph this linear equation, but this time not choosing points, actually knowing what the slope is and what the y-intercept is, and then leaving it at that. And the problem for this expression is it's not written in the form, put it off to the side, f of x is equal to m times x plus b. Or really you could say y is equal to mx plus b. These two equations are saying the same thing. So the equation that we have over here is just not in that form. But it's easy to get it in that form. You can basically just solve this equation for y, and that's what I'd like to try to do. So we have 2y minus 4 is equal to 8x plus 2. And my goal is to get y by itself. You can call it y, you can call it f of x. You are saying the same thing if you do that. So I think I'll start by adding 4 to both sides. So I get 2y is equal to 8x plus 6. And then I'll divide both sides by 2. Which gives me y. And that 2 is divided into both the 8 and the 6 separately. So I get 4x plus 3. And you could also say f of x is equal to 4x plus 3. So if I scroll down just to give a little more space for my graph, that should be enough to place a function on here because I know the slope and I know the y-intercept. So here my slope is 4 over 1, and my y-intercept, 0 comma b, is really 0 comma 3. So to do this, I'm going to start by placing a point on the graph for the y-intercept. So 0 comma 3, it's right here. And as long as you get a second point, that's enough to graph the entire line. And this is where slope is going to come into play. Slope is the rise divided by the run. So when we say rise, we're saying like how far up or down does it go? I see it's a positive 4, so it means the graph is going to go up. And the run is how far across that you go. Again, a positive 1's going to mean you're going to go to the right. So to get a second point, what I'll do is I'll go over one place, and then I'm going to go up 4 places. So 1, 2, 3, 4. So that's a really easy way to get a second point on your graph. And if you understand slope, it has to be that this is the case for any point that you pick on your graph. So let's see, maybe going back up a little bit. If you want to get another point on the graph, same idea. What you would do is you'd say, okay, I would again go over 1 and up 1, 2, 3, 4. So again, we have this other point on my line. If you want to go backwards, you just have to use the same logic. You would say, okay, well, if I'm going to go backwards 1, I'm going to go down 4. So it's going to be back 1, down 1, 2, 3, 4. And this is much more than we actually need to graph the line, but I just really wanted to talk about slope a little bit. It's a number that tells you how do you get from one point to the other on your graph. So if I want to plot the line that goes between these points, let's see, I'll choose a spot here. Maybe I'll select this point. I'll go in this direction. And this would also go in that direction as well. So that is the line that's going through the 4 points that I plotted. Technically, you just need 2 points. So once you put the y-intercept on the graph and you get your second point using the slope, that should be enough to get your entire equation. For example 3, instead of graphing an equation, I really just want to get a formula for the line. Once you have that, you could look at its graph very easily, but if I had 2 points, there should be some linear equation that goes between them. So I should be able to find something of the form f of x is equal to m times x plus b. So we're looking for 2 things. What's the slope? And what's the y-intercept? And I'm looking at my 2 points, and nothing's really telling me what the y-intercept is, but I do know that we have a formula for slope. So that is m is equal to y2 minus y1 over x2 minus x1. So if you look at the 2 points we have, these are your y values, the 8 and the -1. And it's really up to you how you choose the x1, y1, and the x2, y2. It does not matter which order you choose them in. So here's how I'm going to do it. I'm going to say that, all right, I guess I'll let this be y2, and this is going to be y1. And then once you make this choice, I know that the 4 has to be my x2, and the -2 has to be the x1. You could reverse this if you want to. In fact, after we do the example, you could try it, but you will see that this ends up being the same thing. So with the way I've selected it, all right, y2 minus y1, that's going to be -1 minus 8. All right. Now if I do x2 minus x1, x2 is 4 minus, I'm going to be careful here, that's minus a -2. And if I can simplify this, that's probably going to be a good thing. So m is, okay, we get -9 over +6. So that can't be reduced to an integer. It is negative, but maybe simplifying just a little bit further, this is going to be -3 over 2. You can use a decimal if you would like. You can place the negative in the numerator or the denominator or in front of the fraction. I'm actually going to leave it as a fraction, and I'm going to write it as, this is just negative, and then 3 divided by 2. So in terms of my function that we started with, I have half of what I need to know. I know that f of x has got to be equal to -3 over 2 times x. I just don't know what b is equal to. And that's the last step to this problem. What is b? There's not a whole lot of other information to go off of, but we do have these 2 points, -2, 8, and +4, 1. And that's what I'm going to use to figure out what b is equal to. I'm going to choose one of the points. It doesn't matter which one. I guess I'll use 4, -1, just because the x value is positive. I mean, maybe they'll make it easy. But I'm going to take that information, I'm going to plug it into this equation and use it to solve for b. And just keeping in mind that 4, -1 is the same thing as saying f of 4 is -1. So what I'm going to do is, in place of every single x, I'm going to place a 4. So I have f of 4 is equal to -3 over 2 times 4 plus b. And since f of 4 is equal to -1, that's what this is going to become. -1 is equal to -3 over 2 times 4 plus b. To solve this, all right, nothing happens to the -1. Over here, if I want to try to cancel, let's see, 2 goes into itself once, it goes into 4 twice. I'm left with a 2 times -3, so that's going to be -6 plus b. And adding 6 to both sides gives me 5 is b. So I did this by choosing 4, -1. You could have used -2, 8. It should also work out to be the same thing. But this gives me my final answer. My equation is f of x is equal to, so we have -3 over 2 x plus 5. You can even check this by plugging in the points, 4, -1, -2, 8. They would have to make this thing a true expression, but this is our equation. For the last example, example 4, my goal is to find the equation going between the points -3, -2, and -3, 12. And you could use any of the approaches, from the previous examples to like help you through this. Like maybe call it f of x or graph the points and try to figure out the slope. I'm not sure what would be the best approach here, but maybe plugging these 2 points into my slope formula and simplifying it. I mean, seems reasonable enough. We just did it in example 3, so let's try that. I'm gonna scroll down a little bit here. So it was -3, -2, and -3, 12. Maybe I'll call this my x1, y1, and this is my x2, y2. I don't think it's going to matter which order we do these in, but to figure out the slope, m, let's see, y2 minus y1 is 12 minus a -2. And then my x2 minus x1 is -3 minus a -3. And to simplify this, the numerator is, well, 12 minus a minus is 12 plus 2, or 14. And then -3 minus a -3 is actually -3 plus 3. That's 0. And this is not defined. So to see what happened here, if we plot these points, let's see, that was -3, -2, and -3, positive 12, I think I see what's happening. So whatever this line is, it's not a function. If you draw a line going through these 2 points, it's vertical. So there's no way you could express this as f of x is equal to m times x plus b. It's actually impossible to do this. But there should still be some equation that goes between these 2 points. It's just not something of the form y is equal to mx plus b. And it turns out the answer is really simple. Anytime that you have a vertical line, you can write that as x is equal to a number. In this case, it would be x is equal to -3. The reason this works is any point that you choose on this line, wherever it is, it has an x value of -3. Like this one is -3, 1. And this one is -3, 7. So in this expression, there are no y's, which means y can be anything, but the only restriction is that x must be -3, and that's why it traces out this vertical line.